All right, good afternoon, everyone. Thank you for attending today's webinar here, another one in the GatesAir Connect webinar series. This one today is Quality Monitoring for TV Transmission, presented by Martin Horspool, our TV product manager here at GatesAir. And we also have another guest who will attend during the question and answer session, Ted Cordy, who is the Chief Operating Officer at Qligent. Today, we hope to get you some great information. We're going to hold off for a little bit and let more people sign in, and we'll start briefly here in about 3 minutes. Thank you for attending. All right, everyone. Welcome to the GatesAir Connect webinar series. Today, the webinar is on quality monitoring for TV transmission. We're going to talk a little bit about one of our products, in fact, the Maxiva Stream Assure, which is powered by one of our awesome partners, Qligent. Today, the presenter is going to be Martin Horspool, who's our TV products manager here at GatesAir, and he'll be joined during the question and answer session by Ted Cordy, who's the Chief Operating Officer for Qligent. And we hope to give you a lot of great information today, whether you're a single station TV broadcaster or multi-station group or network. And the idea here is to give you strategies and tools, and a really good visual understanding of what things you can see and do with your television stream. So without any further ado, I'd like to once again present Martin Horspool.
Hello, everyone. Good morning, good afternoon, or good evening, depending on where you are. As Keith explained, I'm going to go through a monitoring system that can be used with any TV station or network, can be scaled to suit anyone's needs, and has quite a lot of capability. So I'm going to get started right on it. So some of the things that are driving this type of application and need are the fact that broadcast trends are moving very, very quickly. You've seen a transition from analog to digital in the United States and other countries. There's been some spectrum repacking where part of the spectrum has been reused or used for other services, such as wireless communications. There's also been some shifts in standards, not only from analog to digital, but between digital standards. An example is DVB-T to T2 in Europe and some other parts of the world. In the United States, HSC1 will probably eventually transition to HSC3. Other things that have been changing over the years and very recently, what about the definition, standard definition, high definition, and so forth? Encoding and compression, there's been recent updates. Not too many years ago, we went to MPEG-4. Now HEVC is in the picture. And what's next? There's more and more things coming. On top of that, many broadcasters are requiring or would like to transmit or broadcast additional services, additional programs, data, other services, emergency warning, lots of things. There's a big list. I'm not going to go through everything I can think of, but things are becoming more interactive, and with standards like HSC3, things are becoming more seamless with internet. So the two will sort of almost merge into one event as far as the consumer is concerned. But on top of that, really, there's a lot more things to monitor, a lot more things you can be looking at to make sure your system is clean. And the basic problem is there's more and more pieces of equipment between the origination of the signal or the origination of the service and the end user. So today, it's as I mentioned, it's more than just over the air. There's internet, there's interactive television, there's all sorts of media delivery platforms, and everyone's trying to do more with less, and that often means reduced amount of budgets, reduced operating personnel, and even we've seen a little bit of erosion in technical talents because it's difficult to keep everybody trained, and everybody wants to be working on computers, but that doesn't necessarily mean they're working in broadcast environments. So quite a bit of extra training is often required, but there's never enough time for it. So we believe that competitive environments like this really require, and any station that wants to remain competitive, they should really be very careful in watching, the quality of experience, the quality of service. The higher that can be, the better the satisfaction for the customer. The other thing is that many major network operators have service level agreements. They have to comply and conform with contractual parameters. Very, very important. So I'm just going to quickly go through a couple of, well, actually 4 definitions. First of which is what I would call performance monitoring. And a monitoring system like this is something that most TV stations and radio stations in this country already do. They monitor things like power levels and technical parameters such as SNR, signal to noise ratio, modulation error ratio, shoulder levels. What's the frequency? Is it within the standards? Things like this are being done today. You need to for FCC and other government requirements. Well, that can be tracked and monitored over time, and log tables can be produced. It's not necessarily the best indicator of quality as perceived by the end user or the customer. So there are some other terms that have arisen over more recent years, particularly through web and internet and other services like telephony, quality of experience. And that's really a measure of the delight or annoyance of a customer's experience. How well is the service providing what they need to get from it? Is it really enjoyable to watch or listen to or not? And that's a very important parameter, I think, to be monitoring. Closely related to that is quality of service. And this is something that can be a bit more quantitatively measured. Quality of service can include things that can be measured like packet loss, bit rate, throughput, things that are mentioned here. Many, many, many items can be monitored and checked that within the given parameters, the intended parameters of that delivery system. So that can also be used very usefully by a broadcasting service or a network. The other thing that comes on top of all of these things is something called monitoring as a service, or MAAS. This is basically derived from cloud computing delivery models, and the idea in a nutshell is that the common application here would be an online or online state monitoring system which continuously tracks certain states of applications, network systems, or even a broadcast network over a period of time, usually deployed through the cloud or an internet service of some sort. So going back briefly to performance monitoring, as previously noted, it's a commonplace. It's a requirement of TV and radio broadcasting. There are several mandatory required parameters to be measured. For instance, RF power level has to be within certain limits. This must be controlled and maintained within specific levels. So many newer designs of transmitters, including all the current products from GatesAir, have an integrated performance monitoring capability. It isn't necessarily monitoring everything, but it's monitoring pretty much everything within the transmitter itself that's important to the operator. And you can basically quickly see that it's on the air, it's running, there are no faults, there are no status or warnings, or if there are, you can work on those. It also has integrated a simple but easy to use remotely or locally performance monitoring, where here we can measure lower sideband, upper sideband, quick plot of the spectrum, also error vector magnitude, SNR or MER, depending on the modulation. So that's very useful, but does it give you everything you need to know? Not necessarily. So on a system level, there's a bit more you can be looking at. It's more than just RF. One thing that can happen is the viewer calls in, I've lost your picture. Have you actually lost the transmitter, or is it something ahead of the transmitter? Is it something else? What could it be? It could even be, of course, at the viewer end, but you don't know. So it's be nice to be able to monitor and analyze different parts of the overall system to maintain good quality of experience for the viewer. So here's what do you do? Where do you look? So that's the main thing. Well, one solution that we're working with Culigent on, and we've deployed some of these, is called StreamAssure. StreamAssure is basically can be configured for a very simple system, and the one shown on this slide is pretty straightforward, but we're not monitoring only transmitter parameters. We can do some monitoring of the transport stream ahead of the transmitter, and that may be in more than one place, but you can certainly do it anywhere ahead of the transmitter, or you might want to do it at the RF output somewhere, or even at the receiver end of the network if you want to. There's various places that you could monitor the integrity of the signal and look for performance changes and other parameters. So the idea is that you would have a system of probes or edge devices and some external apps at various places to capture and measure data from these sources throughout the chain. The aggregation of the data from multiple sources allows a simple means to visualize and analyze the data as needed. The slide that's up now shows a slightly more complex but still very, very, very doable system application here. In this diagram, we show multiple probes located at various points along the signal path. This includes monitoring of the ASI or baseband signals at the studio, monitoring the signal into the studio transmitter link or STL, also monitoring the signal at the receive STL and just ahead of the transmitter, and then through the transmitter as monitored within the transmitter itself, and then also at the RF output. And then beyond that, you could even have an off-air receiver or some other app that's connected downstream from the received signal to see if there's a problem down there as well. And all of this needs to be aggregated into a server and then displayed somehow. So what StreamAssure does, the architecture very simply is shown here. There's some semi-manual functions where you can simply visualize, analyze, report, repurpose various things. There's some automated functions built into the system. So this helps us enable functions like quality of experience, quality of service. Are we in compliance? What's the health of the equipment? And then there's sources, and the sources can, as I mentioned, can be RF, can be ASI, could be an IP stream or IP itself. And the architecture is very useful in situations like this, where we're showing what happens along that signal path, there's a lot of things happening, and you want interoperability between these things, or embedding, de-embedding, inserting, extracting, and so forth, encapsulating. And all these things can, if not done correctly, or the various components in that signal chain or path are not interoperable correctly, things can occur along that path to break up the signal, cause glitches, loss of data, delays, lots of things can happen. So it's very important to monitor throughout the stream and not just at one single point. So what sort of things, you're probably asking, what sort of things can be monitored or analyzed and recorded? Well, here is a list of some of the things that can be done. The RF layer analysis, transport stream analysis, ASI, transport stream, coming in, a multiple or single audiovisual QoE analysis and so forth. I won't read everything on the slide, but you can see there's quite a bit of capability built into the system. And that includes, as I mentioned just now, compliance recording and so forth. And then future modulations like HSC3 coming. Well, monitoring of that is also in development for Stream Assure, so that will be forthcoming. The table shown on this slide, this is now visible, shows what we are selling as various systems. And you notice there's 3 columns down the middle of that chart, Express RF, Express ASI, and Pro. Basically, those are going from, 2 simple solutions looking at RF and ASI, and Pro, which covers both of those, plus some more capability. So you can certainly go from a very limited set of features up to a very fully loaded professional system that does everything, including capturing raw data, recording video and audio, where you can certainly store it, play it back later, and look for glitches. You can also correlate and align faults to see where they are. It goes quite involved at this point. So there's quite a bit of analysis that can be done, particularly with the Pro version of this, which also includes macro blocking detection, which I think would be very useful. So one thing that's very, very good about Stream Assure is it's not just necessarily monitoring one site. I know many people that have called in probably only are concerned about one particular transmitter site because that's their transmitter station. But if you think of it from a network point of view, your network operations center could very well want to monitor in one location everything in the network. And there are such things as NMS systems that currently do things like that, but they don't necessarily have the the depth of monitoring at all the various points that Stream Assure has. And the map shown here is just a map of Russia where there's already some systems deployed. You can cover very large geographical areas, and you're pretty much unlimited to the number of sites and number of data points where information can be collected. Speaking of monitoring, there are actually various layers of signal that can be monitored simultaneously. Excuse me. These include the video layer, audio layer, data layer, transport layer, as shown here, and going from the transport layer into the RF layer. So all of those 5 layers can be monitored simultaneously. And by doing so, if you do see a problem somewhere, you can sort of correlate the data across those layers as you're monitoring them to see where the source of the problem might be. The Stream Assure system itself has what we call a dashboard, which is basically a screen on a monitor, which you can basically set it up any way you want. Different user displays can be created as a dashboard. You can have different views. This particular one shows 4 views, including RF measurement and a few other screens, like a map of the monitoring network and a few parameters that you might want to put on the top layer. But you can certainly, at any point in time, drill down and go much deeper into the system and look at any particular parameter or measurement. So for example, here's another screen where we're just showing MER tracking over time. So you can have certain thresholds set. In this case, we have a threshold set at about 24 dBs. If the level drops to that, you see a color change. If it keeps going down, you have a serious problem. In fact, at that point, obviously, your viewers are not going to be able to receive a signal. You know that there's a serious problem. You can always wind this back, recording the data over time, and you can go and see where these glitches occurred. Another screen is a multi-program, multi-viewer type of view where, let's say, you're monitoring different services that are transmitted over one channel or various channels that are transmitted simultaneously. For instance, they could be, your main program, and then your 12.1, 12.2, 12.3 programs, your other little programs that are being transmitted at lower data rates. I want to be able to see all of these at the same time. And that's easy to do with the system. And that multi-program view doesn't necessarily have to be 6 screens like this. It can be more or less. And the little green bars, it's a bit hard to see to the right, are actually looking at the various, at the 5 layers of the signal that we're monitoring and analyzing at the same time. Another view here is, this particular one is just an example of how deep you can go. Here we're looking at the bit rates for each program and transport stream verification. In this case, we're doing HSC A782015 transport stream verification. Another screen is a bit of an eye chart, unfortunately, because there's a lot of information on it. It's actually just an alarm screen. You can see various levels of alarms shown where, normal type of status are not colored in at all. A warning will be yellow, and a severe issue can be highlighted in red, or, as you want to do that. And all of the dates and times are stamped in here when the fault occurred, when it cleared, or if it's still ongoing, and what the fault status is and what type of fault it is, and so forth. So a question we might get asked is this an NMS system, a network management system? No, it's not. A network management system is something that connects to equipment. It aggregates equipment data and analyzes the health of the equipment. StreamAssure is different. It connects to streams. It aggregates the stream data, and it analyzes the health of the streams. You can see it's doing a little bit different thing. One nice thing is these two things can be merged together. So StreamAssure can work very well in conjunction with an NMS system if you already have one, or if you're thinking about purchasing one, as shown on the next slide. So the systems are very complementary. If you have both, broadcasters can leverage their existing investment. You don't replace an NMS system. You can use it with StreamAssure by adding quality of service, quality of experience type measurements to it. So you're not only connecting to the equipment, you're connecting to the signals. You're not only aggregating data from the equipment, you're aggregating signal data, and also the health of the equipment with the health of the signals. So you're doing both, which can be a much more powerful tool to you, the broadcaster. So here's some use cases, things like visibility. Now it's possible to make visible things that were previously not visible to you, allowing the operator to experience what the viewer experiences. You can see what he's seeing. Regulatory, think about that. Regulatory compliance. Now it's possible to automatically monitor and track key performance indicators that previously would have been very hard to monitor and track. For instance, loudness. That's one thing that can be monitored with StreamAssure. Service level agreements. Often a network operator must have proof that the broadcast system meets the SLA compliance levels. So you can also use that to verify that the commercials were played out correctly at the right time with no blackouts or no glitches or no freezing of the signal. Things like that are very important to revenue. Optimization. By tracking and analyzing the streams and RF, it becomes easier for the operator to optimize and improve the overall system performance. And then impact analysis. Did the issue cause the transmitter to go off the air? Was the transmitter off the air? Was the issue somewhere else? These types of things can be analyzed more easily with StreamAssure. And there's some transitional use cases shown here, like during system upgrades. How well was the system performing before the upgrade? And how well is it working afterwards? Did you improve the system? Is it worse? Is it better? You can do things like that. You can also look at tracking down intermittent system issues. These historically have been very, very hard for the broadcaster to understand what happened. About monitoring the system in many, many, many places, the streams, the equipment, you can really kind of see a much better opportunity to see where the system intermittents were being created. And then you can record, look at trend lines, and have alerts at different levels and things beyond that if you want to. Root cause analysis, terminology often used but difficult to implement. This certainly helps you do that because you can capture the data, you can record it, you can correlate it, you can look at trending, and you can basically look at all that data at any point in time and see what happened exactly. And then there's system baseline, proof of performance and tuning. So basically you can see where you were at the beginning when you first installed the system to today and see if anything has changed. You can see, if things are still in alignment and working correctly. Return on investment is very important to every broadcaster, I'm sure. Cost reduction is something I think StreamAssure would help. It certainly can accelerate projects. It can reduce manpower because it's doing the work of many things in many different places at the same time. Management by exception is noted here. Can accelerate troubleshooting by a factor of, we believe, up to 3 times, because you can more easily see where problems are occurring, if they occur, and where they occur. It consolidates the functions of 8 or 9 purpose-built test and measurement boxes. You can think about something just analyzing the stream, something else just analyzing the RF, something else just analyzing video, something else analyzing loudness, and so forth and so forth. This does all of that in one box, so it can certainly save some costs there, a significant amount of money. And it can be integrated with existing gear, like I've just mentioned. There's some risk mitigation shown here. Proof of compliance can be demonstrated very, very quickly. You can automate reports, recordings, things like advertising, subtitling, and captioning, and all of those types of things can be automated very quickly. And by using this correctly, can help prevent reoccurrence of common issues, because you've solved the problem, you know what happened. And of course, brand improvement. If you can reduce your off-air occurrences, it can improve the ratings. It can basically improve the enjoyability of viewers and listeners to your programs. So, in summary, one of the things that's very, very good about StreamAssure is it's very flexible in terms of scaling and sizing. It's very scalable. It can be sold and used as a single system, monitoring a single transmitter with maybe minimum number of probes. You're only monitoring the stream in one place, the RF, and maybe the stream in one other place. Very, very simple. Or it can be expanded to multiple systems over a large network over an entire country. It can be used for compliance recording, streaming, monitoring. It can basically go well beyond most test and measurement solutions, because this can do quite a lot of transcoding, recording, and the capabilities are very, very deep. Has a very good user interface. The main screen, including all of the various levels that can be shown, the dashboard that's flexible, and you can drill down in depth and look at exactly what happened quite quickly. Becomes very useful. And it has good fault analysis and root cause analysis that basically built into the system. So on that, I'll ask Keith if we have any questions in yet, or certainly if anybody has any questions, please send them in. Thank you.
Yeah, thank you, Martin. Yeah, basically with Q&A, we're going to take care of right now. Any questions that you might have, if you're viewing this on gatesair.com/webinars/quality monitoring TV transmission, you will notice there's a live chat below this video. As well, if you're watching it on YouTube directly live, there is also a live chat window, I believe, to the upper right-hand corner. And definitely ask any questions you have, and we'll see if we can answer them here live. And if not, we can definitely send someone, get someone to email you back and get that information to you. I do want to thank the people that also have emailed in questions in advance. I think we're going to try to get to those first, and then we'll see what comes up on the live chat. But for right now, let's see, Jolly Roger, great name, asks, can StreamAssure also monitor for data services such as captioning and subtitles, SCTE35 triggers, and ratings watermarks? I'll see if Martin, or again, we have Ted Cordy from Qligent on the line as well to field some of these questions. Hey, Ted, are you on?
Yes, I'm here.
Sure. Would you like to field that first question about monitoring data services?
Yes, it does monitor. I believe you called out 3 different data services: the City 35 and also 104. We also do look at Nielsen watermarks, including verifying the correct station and program PIDs. And then there was also, let's see, the ratings, the ad insertion, and what was the third one? that you mentioned?
Oh, really? Just general captioning and subtitling.
Yes, we do. We detect presence or not, and plus the system will actually, in its compliance recording, record the audio bars, the captioning, the program ID and time of day, etc., into a low-res copy of the video, and makes it easy for you to call it up whenever you want.
That's awesome. All right. S. Lee asks, can I get text or email alerts? What kind of notifications can come in through StreamAssure?
That's another good question. So from the UI itself, you can get, configure it to be flashing if there's an alarm, around the PIDs in a lot of different ways, as well as audible alarms. It does do. You can configure it to set out text messages like, "Hey, there's a problem. You're black on air," whatever. You can also send out emails. And it'll also send out SNMP traps if you have a network management system or facility remote that you want to tie it into.
And there you go. RTX Surf, I think I'm pronouncing that right, asks, how long are video recordings available and logged with StreamAssure?
Yeah, that's another good question. The system itself is not limited to the amount of storage or record time because it's cloud enabled. So in essence, if you did have some sort of cloud enabled solution, you could pay Google, Amazon, any of those guys as much as you wanted to store it as long as you want. But it seems like the optimal size for StreamAssure is, again, it's based on number of bit rates and everything else that you record at, but it's a minimum of 7 days and up to a month. But on a special request, you can always add more storage.
Do you have control? I'm assuming this is more of the choice of cloud, but as far as being able to move those recordings to other locations, store them offline?
Yes, that's another very good question. To manage whatever storage you do have, straight from the user interface, you can export, one clip at a time, or you can actually set up the system to do a file transfer to a specific location. You basically set up the file transfer, and then it becomes a pull-down menu, or even automate it. And then you can also do a file transfer on a schedule. And these are people who have, bandwidth limited systems, and they want to basically move things off in a batch, for instance, overnight. So it'll handle all three modes.
I've got one more question from the emailers. Jim Bullock writes in and asks, how expandable is StreamAssure or the products that we're talking about with monitoring?
Yeah, good question. The StreamAssure, it comes in a single box solution. That's it's an initial start where you basically wrap it around the transmitter, as Martin Horspool demonstrated in the presentation, and then from there you can add additional transmitter sites. For instance, if it's a broadcast station group, or you can put another probe at a station. And then also in a coverage area, if you have complaints about, poor coverage in a particular area, we can even instrument, a smaller, lighter weight probe out in a coverage area, and then you can basically pull all that telemetry, and it'll, do the trend analysis over time to help sort out any kind of coverage area problems. So yeah, it's very expandable. We've done systems with thousands of probes.
Very cool. I had a question actually about just the interconnectivity, I guess piggybacking off of expansion capabilities. Martin was talking a bit about how we can't really consider StreamAssure as an NMS, but as far as if you could talk a little bit about, I guess, a reach out and a connection via like SNMP or what kinds of opportunities do you have there?
Yeah, the two main ways that we've integrated with other systems is either SNMP or JSON, which is a common web interface type of.
That's my talk. I'm the web. I'm the marketing guy, so I'm a web nerd. I like JSON.
Okay.
Yeah.
Yes. But yeah, as Martin mentioned, the systems can be very complementary. Back in the, before things were digital, the problem where these kinds of systems came along was because of the nature of digital video, and it's very dynamic. So even encoding is very program dependent. So if you have high motion versus talking heads, you got different bit rate. So you got this variable bit rate, and then you have stat muxing. And what happens is that whenever you go from, talking heads to, a sports update and the stat mux, and then boom, you got this big bump in bit rate. And what that does is it causes starvation of buffers. And then what you'll see is the picture kind of freeze, pause a little bit, break up, and then come back on its own. So nothing was broken. Nobody did anything to fix it. It's just kind of the nature of digital systems and trying to get as many bits out to the end user as you can. So that's how systems like StreamAssure came into existence, because there was nothing else on the market that could solve that. And you have to have something running more or less 24/7 instrumented, because these problems come and go on their own, and you don't really realize how often this is occurring without it.
Mm-hmm. All right. So we actually have a few people who have commented on the live chat. But there's a good question here from Dave Glenn. He was pointing out how Martin did mention how StreamAssure captures audio VU levels and loudness and things like that. But he wanted to know, does StreamAssure also monitor for COM Act compliance, which I believe is the loudness, too much loudness for commercials? Am I right about that?
Yes, that's correct. We do follow the A85 loudness standard, as well as the European ones. Forget the name of the actual European standards, but yes, we do follow the COM compliance, and we can alert and alarm on any kind of violations and actually create a report of it. So it's not just if you violate it, it's how much did you violate it from, because a lot of times you get hit just at a hairy edge, and then it looks like you've been in violation all day, but you're out by a 1/10 of a dB, and I doubt the FCC is going to fine you over that, and it'll provide all that proof of performance for you in a report.
That's valuable. Literally. Let's see, at this point, I probably shouldn't comment, but actually it's kind of funny. Earl Flanagan had a very funny comment saying how the QoS on this video stream is horrible. Haven't been able to read a single line of text due to poor resolution. You might want to use StreamAssure on it. So which is very awesome. And yeah, so sorry if YouTube isn't necessarily working that well for you. It's probably due to maybe personal bandwidth issues. I know YouTube has its own adaptive, bandwidth, just reordering of what your quality of your stream is going to be. But I would recommend, this is an awesome segue for me to point out that we are recording this webinar, as all webinars, and I would definitely recommend, Earl, that you actually rewatch the video at your leisure, and on YouTube, on our YouTube channel, which is youtube.com/user/GatesAir. And it should be available shortly after this presentation, I would say within 5 minutes. And I'm pretty sure you'll be able to read and see quite a lot of a better quality image, a 1080p image, in fact. So but yeah, can StreamAssure hit YouTube, Ted?
Yeah, actually we do. We have OTT solutions, and yeah, we could help solve these kind of problems that you're experiencing with the video conference. But we can instantiate virtual probes pretty much anywhere, and then through cross correlation and the process of elimination, we can find out if it was the OTT provider, the the transcoding streaming, the CDN, or even an internet service provider. And if it's none of the above, then it might have been just a user. But then we can also correlate that across all the different areas and find out where you have choke points. So that's the nice thing. We call it cross correlation. Other people call it artificial intelligence. I think it's a little ambitious to call it artificial intelligence, but it kind of is.
Just call it real intelligence.
Well, it definitely automates, analyzing a lot of different pieces of data at once. So that's its really nice sweet spot about it.
Yep.
Awesome. So Google and YouTube, if you're listening, I'd like to introduce you to Martin Horsepool and Ted Cordy here. We'd like to talk to you about a little UOS on your little unknown service here. So yeah, and for right now, it seems like the live chat is, COM itself to take that acronym a little farther. But I think at this point, if people had extra questions to run past you guys directly, how Martin, would someone contact you?
They can contact me directly at martin.horsepool@gatesair.com. And note, Martin is Martyn, and Horsepool does not have an E in the middle. So
there we go. And Ted, how about you?
Yes, it's Ted, TED.Cordy, KORTE @QLIGENT.com.
Awesome. And again, my name is Keith Adams. I am the marketing guy. So if you have any questions that I might be able to answer, or in fact, if you have any ideas of webinars that you'd like us to, any kind of topics you'd like us to attack in upcoming webinars, please feel free to contact me at either kadams, with KADAMS @gatesair.com, or directly to marketing@gatesair.com. I've got some options for you. So in the meantime, thanks a lot again for attending this webinar. We appreciate your attendance, and we want to keep you in the loop with other ones as well. So thanks for registering. And we also hope to see you at this year's NAB if you get a chance to stop by Las Vegas. I believe it is April 9th through the 13th, 9th through the somethingth. And we actually have a special event on the 8th, Sunday the 8th, at the Las Vegas Country Club. You can contact us at the website and contact me as well to learn a little bit more about how to see us live and in person. Our booth number is N3703. We're in North Hall as usual, and we'd love to see you there. So in the meantime, again, thanks for checking out our webinar, and we look forward to seeing you at the next one. Thanks, and have a great day.
Thanks, everyone.
Thanks again, Ted.
Yes, thank you. Bye-bye.